हेलो माय डियर स्टूडेंट्स, वेलकम टू बायजूस एग्जाम प्रेप। आज इस संडे के फंडे के वीडियो में विल बी डिस्कसिंग अबाउट द कंसेप्ट ऑफ ऑसिलेटिंग फैन। यू विल बी सरप्राइजिंग टू नो दैट ऑसिलेटिंग फैन का जो कंसेप्ट है उसमें हम लोग थ्योरी ऑफ मशीन के कंसेप्ट के ऊपर डिस्कस करते हैं, दैट इज द 4 बार मैकेनिज्म। लेट अस हैव अ लुक। और उससे पहले आपने देखा होगा जब भी हम लोग ऑसिलेटिंग फैन में एक पुश बैक बटन होता है, जैसे उसको प्रेस करते हैं तो आपका फैन ऑसिलेट करने लगता है, और जैसे उसको पुल बैक करते हैं देन द फैन इज नॉट ऑसिलेटिंग। तो उसके पीछे क्या कंसेप्ट है एक बार यहां पर भी देख लेते हैं। अब यहां पे अगर मैं बात करूं, एक हैंगिंग फैन है तो उसमें पुश बैक बटन की जगह थ्रेड्स होते हैं। तो इफ आई ट्राई टू पुल दिस, अब आपका फैन रोटेट करने लग रहा है। बट इफ यू ट्राई टू विजुअलाइज, इफ आई ट्राई टू पुश दिस ऑसिलेशन, तो जो ऑसिलेशन का जो एक्सिस है वो डिफरेंट है एज कंपेयर टू दैट ऑफ द रोटर एक्सिस। तो डेफिनेटली कुछ ना कुछ इसमें मैकेनिज्म होगा, क्योंकि सिंपल गियर बॉक्स से ये हम अचीव नहीं कर पाएंगे। तो गियर बॉक्स के साथ साथ हमें एक 4 बार मैकेनिज्म का कंसेप्ट को इसमें इंप्लीमेंट करना पड़ता है। सो लेट अस वॉच दिस इन डिटेल इन द सेकंड पार्ट। Hello my dear students, welcome to BYJU'S exam prep. So let's continue our discussion on this very interesting topic of oscillating fan in this Sunday का फंडा। तो अब हमने we have seen in the practical in the previous video, we have seen that how the fan is oscillating very easily, but the thing is the fan's rotor's axis of rotation is, it is rotating like this, it is rotating in this plane, but how it is gonna have an oscillation motion like this. So definitely here we're gonna use a concept of 4 bar mechanism, that is your Grashoff's law will be used in order to have a detailed discussion, because if you're having a clarity of Grashoff's law, then only we'll be able to understand how we are implementing the Grashoff's law in this. So I'll be explaining you what is Grashoff's law and also how this Grashoff's law, the 4 bar mechanism is being used, the concept of 4 bar mechanism is being used in this oscillating fan very easily, right? Because many students don't have that concept, because if you try to see the same thing, it is rotating about this axis, but how it is having a oscillatory motion, that is important. How it is converting one of the motion into the secondary, that is an oscillatory motion. That means the complete rotation motion is converted into a rocker or an oscillatory motion. That means for that, let us first of all understand what is the concept of 4 bar mechanism. It's quite easy. If you're having a 4 bar connected by 4 turning pair, if you're having 4 bar connected by 4 turning pair, so let us suppose I'm fixing this link, right? And this is the shortest link, which we always call it as crank. This is the coupler link, right? This is the output, or also we can call it as the follower ring. Okay, so basically here what we try to understand is we are applying the concept of Grashoff's law. What is Grashoff's law? The summation of the length of the shortest and longest, if it is less than equal to the summation of other 2 links, then if you're fixing the shortest link, we'll be getting the double crank mechanism. That means both input and output will be having an we can say rotational motion, right, or crank motion. If you are fixing adjacent to the shortest link, you will be getting a crank rocker mechanism, and if you're placing the shortest link over to the coupler position, then we'll be getting the double rocker mechanism. We have seen this in a Grashoff's law, but how this concept is being implemented in oscillating fan, let us hear out in this video. Right now, we know that what is a 4 bar mechanism. We are having a fixed link. Definitely, we'll be having a fixed link. We'll be having a crank or a shortest link, right? And every single link is connected by a turning pair. Okay, this is a turning pair. If you try to zoom it, right, so we'll be able to see very clearly that about 2 joints will be having a turning pair. So now let us try to visualize what is happening in this particular linkage. Okay, now if you try to visualize what is happening is we are fixing this link, right, and this complete motion, that shortest link is, this yellow one is the shortest link and it is kept at the coupler position. That means the shortest link is making a complete 360 degree. If you try to visualize, it is complete 360 and we are getting a oscillatory motion. So definitely this kind of arrangement we can use in our oscillating fan, right? So let us try to see how this is being used in this case. Now if you try to visualize, this is the motor of the fan. Okay, so this link is being the shortest link. This is this is the fixed link. Okay, this is the fixed link, right? And if I talk about the next one, this one is the next link, right, which is having the red color. Okay, this one is a blue color, this one which is fixed link, which is being shown over here, right? Okay, so this is a red one which you are seeing over here, right? After this, the after this, if you try to visualize, this complete motor will be the link. This is link number 1, this is link number 2, this is link number 3. The motor is complete link number 3, because if you try to write the same number over here, this is link number 1, this is your green one is link number 2, this is link number 3, and the shortest link is link number 4. Okay, so if I try to use the same nomenclature over here, link number 1, link number 2, the complete motor is link number 3, and the connection between the motor and this link is link number 4. So we are basically arranging this 4-bar mechanism in our fan rotor or oscillating fan. If you try to quickly visualize, what is happening is link number 1, this is link number 1. Okay, link number 2, what is link number 2? This one, this green one is link number 2, this is your link number 2. If you're able to visualize this clearly. Okay, fine. If I talk about link number 3, the red one, the complete motor is link number 3, because we want this complete system should have an oscillating motion, right? And the connection between these two, the motor and this linkage is your link number 4. Okay, fine. So we have seen how these 4 different links are connected with each other. If you try to zoom it, okay, so we are having this as the fixed link, this as your link number 1, link number 2, this complete fan is link number 3, and this connection is link number 4. So now what is basically happening is, if I able to provide a crank motion to this link, if I am able to provide crank motion to this link, the complete system will be oscillating. Okay, the complete system will be oscillating. Is this clear? If I try to provide a crank motion to this yellow one, the link number 4, the complete system will be oscillating like this, and this is basically used in our oscillating fan. But the problem over here is, sir, how we can give the continuous rotation motion to this, because it has to be rotating. If I say this is the link number 4, it has to rotate like this, but the fan is rotating in different plane. The fan rotation, the rotor rotation is in different plane. How we can convert this? How we can shift that motion to this particular link? For that, we are using the concept of your gearbox. Okay, we are using the concept of gearbox over here. If you try to visualize, the complete system of gearbox will be present inside this. Okay, fine. If you see, what is happening is, this is a worm gear. Okay, this is a worm gear, right? So this worm gear is connected with the rotor or the fan. So this worm gear will be converting its motion in a perpendicular direction. Okay, this is a we can say gear, right? It is connected with the gear, and in between this will be having one pin, or we can say pinion, and this pin will be connected with this gear, and this gear is connected with the gear, the link number 4, and that is the way of providing that continuous rotational motion like this. Okay, so if you try to see the animation, that will be very much clear. This is the worm gear connected with the axis of the fan, right? So once this is connected, right, it is transmitting its motion to one of the worm gear. Okay, this is your worm, and this connected with the worm gear, and there are two advantages over here. There are two main advantages. The first advantage I'll be telling you right now, it is able to transmit the motion in a perpendicular direction. The rotational axis was this one. Now the rotation has been changed perpendicularly, and we wanted that perpendicular shifting of motion, right? So this worm and worm gear, the first we can say advantage we have seen. The second advantage we'll be seeing the later on stages. So we have converted the motion in a perpendicular direction on a worm gear. Now this worm gear is connected with the help of a pin. Okay, so this pin will be transmitting the motion to this green gear, right? And this green gear is connected with link number 4, the shortest link, and this way the fan will be oscillating very easily. Okay, very easily it will be able to. But the problem is how you can, because sometimes the fan is oscillating and sometimes the fan is not oscillating. So definitely we have to use a special mechanism to this. We are using the concept of ball bearing. Okay, what we do is, we try to fix, like if you have seen in the previous video also, when I try to lift that, there is a notch, like we have tried to lift that notch, then in that case what happens? The complete system is stationary. The fan will be giving the fan orientation will be in the same direction. When we try to push that pin, the complete system is oscillating. So same thing is over here. When this is lifted up, okay, there is no engagement. They won't be having any circular motion being transmitted. But as soon as we are pushing this downward, then what happens? The engagement will be happening, and we will be able to transmit the motion very easily. Okay, we'll be able to transmit the motion very easily. If you try to see this over here, when we are pushing this downward, this yellow one is being engaged with that gear, and we are able to transmit the motion in an oscillatory way. Okay, fine. Fine, there's a ball bearing, it is being inside this and it is being rotated. That means when you push the pin downward, this ball bearing, it is having spring, right? So when it is go inside this, it will be interlocked over here and will be able to transmit this motion. And once the motion is being transmitted to this gear, okay, it will be transmitting the motion to the green one and green one to gear number 4. So this way our entire system is being, we are using the concept of 4-bar mechanism in order to have that beautiful oscillating fan mechanism. Okay, fine. I told you I'll be telling you the second important aspect of worm and worm gear. Why we are using this worm and worm gear? The first one is to transmit the motion in a perpendicular direction. The second one is, if let us suppose if you are not using a worm and worm wheel, then the rotor, the fan is rotating with very high RPM, and if I'm giving that same oscillatory motion like this, failure is going to happen. Okay, if I'm not using worm and worm gear, then what will happen? This will be having a very high oscillation and the complete system will be undergoing a failure. So that is the reason, because worm and worm wheel is having a very good property. It is having a huge speed reduction ratio. The speed reduction ratio or the velocity ratio, or we can say it is a classified, worm and worm wheel gear are classified as having a high speed reduction ratio or speed reduction gear, right? That is the reason, two very important advantages of worm and worm wheel: to transmit the motion in a perpendicular direction and to reduce the RPM, because if you are using the same RPM, this is going to happen. Okay, fine. So this is all about our very beautiful concept of the worm and worm wheel, right? And the oscillating fan we have understood in a very detailed manner. I hope so you all like this video. Please do share this video to all of your friends, because the more you share, the more students will be able to understand the concept of this. So thank you guys for joining with me. I hope you all enjoyed. Stay connected with BYJU'S Exam Prep for more such awesome content. Thank you guys. Bye bye. Take care. Stay safe.